All right, so today we are going to be looking at double angles. If you look on your yellow formula chart, you will see that we have three different identities that all say cosine 2 theta. And then we have one for sine of 2 theta. And then we have one for tangent of 2 theta. So these are the 5 identities that we are going to be working with today. So the first thing that we're going to do is we're going to simplify using the double angle identity. So we have the problem sine 2 theta times secant theta times cosecant theta. And so you want to notice that this is a double angle. You'll be able to spy the double angles because there'll be a 2 multiplied by theta. And you'll go down on your formula chart and you'll see that the sine of 2 theta is equivalent to 2 sine theta cosine theta. So we're making a substitution for that double angle into this expression. So this is our double angle identity. And I'm just going to bring everything else down. So at this point, we've got sine, we've got cosine, and we've got secant and cosecant, and we're trying to simplify. So what else do you guys think we can change? Yes. Go ahead. All right, what is cosecant equal to? 1 over sine. I think that would be a good choice. Anybody see something else? Secant would be changed into 1 over cosine. So let's go ahead and do both of those at the same time. So secant is 1 over cosine, and cosecant is 1 over sine. And those are both reciprocal identities. Now notice that everything is being multiplied together. If you would like to place this first term over 1 to make it look like a fraction, you can. It's not necessary. And then multiplying fractions, that's no problem. Top times top and bottom times bottom. So if we carry out our multiplication, our term will just look like this. And then because we are now down to just multiplying, we can go ahead and divide out those common factors. So cosine divided by cosine is 1, and sine divided by sine is 1, and 2 times 1 is 2, and so that would be our simplification for that trig expression. All right, now we want to move on to verifying or proving with the double angles. So when you see these instructions, verify or prove, those are synonyms of each other. And remember, in this case, we don't really know if they're equal. So sometimes I like to come in here and put a question mark on top of the equal signs. We are trying to determine or to at least prove or demonstrate to someone else that those are equal. So this is where we can't do things on both sides because we don't know if there's equality there. So we only want to work on one side. You can work on either side that you want, but you want to work on the side where you can see a substitution. So So since we're focusing on double angles today, do you see that you have cosine of 2 theta here? So look on your double angle identities. The issue with cosine is you have 3 choices of what to plug in. Now you can do this proof with any one of those choices, but one of them is going to be way easier than the other 2. So you take a peek at your other side. You want your other side to be cosine squared theta. So do you have any need of having sine theta in your problem? No. So that's why I would say let's choose the middle cosine double angle identity. So we're going to substitute that and have 1 plus 2 cosine squared theta minus 1 all over 2. So I took this cosine 2 theta and substituted this double angle identity. Oh, well, look how nice that is. Can I do 1 take away 1 is 0? So then I'd have 2 cosine squared theta over 2. What did I do? I just did a little subtraction there. And then since I have multiplication, I can do 2 divided by 2 is 1. Just did a little division. And that leaves me with cosine squared theta, which is what I was trying to prove. So QED, quod erat demonstratum, it is demonstrated. Ta-da! Yes?
How do we know that the double angle identity, I guess, like how do we know like sine 2 theta is equal to 2 sine cosine? Like, how does that make sense?
All right, we will go through the proofs of these next week as to why they are what they are, but right now we're just, it's an identity and it's always true. But it can be proven. We'll get to that. All right, now let's take a double angle and solve an equation. So in these instructions, we are asked to solve over the interval 0 to 2 pi, and we are given sine of 2 theta minus sine of theta equals 0. So first of all, notice that I am taking the sine of 2 different sized angles here. So the way this is written right now, I cannot combine these in any way. These would not be considered like terms. So my only choice is to come do a substitution with this double angle. So if we look on our formula chart again, sine of 2 theta is 2 sine theta cosine theta, and then bring down your minus sine theta is equal to 0. All right, at this point, we have it set equal to 0. Do you see anything that we can factor out? All right, very good observation. We've got a sine theta in our first term, and we've got a sine theta in our second term. So that's a common factor. So we're going to factor that out. So that's going to give us sine theta times 2 cosine theta minus 1. So that's an algebra skill of factoring out a common factor. And the beauty in factoring is that now that I have 2 factors that multiply to equal 0, I know that one of the 2 factors has to be 0. The only way you're going to get the answer of 0 in multiplication is if one of your 2 factors is equal to 0. So I'll set each one equal to 0. Sine of theta equal to 0. That's my first factor. 2 cosine theta minus 1 equals to 0. That's my second factor. Then I work with each of those equations. When is the sine of theta equal to 0? Those 2 points in our unit circle, right? And so theta is equal to 0 or pi. Now, why am I not going to say 2 pi? So my interval that I was asked to solve over has parentheses here, which means 2 pi is not included. All right, now I work out my other little equation. I add 1 to both sides. So 2 cosine theta equals 1. Divide by 2. Cosine theta equals 1/2. It's a positive 1/2. So what would theta have to be for the cosine to be positive 1/2? Pi over 3 in the first quadrant. And what other one? 5 pi over 3 down in the fourth quadrant. That's where cosine is positive. So those are my 4 solutions. Now, keep in mind, if you wanted to check this, you could go back to your original equation, right? And you could take each one of these values for theta and type it in. So you could type in sine 2 times pi over 3 minus sine pi over 3, enter, and check to see if it equals 0. So just remember that you can check with the calculator.